Any questions before we start? I just want to end this with one problem, and that bandpass problem we had been doing, and then we can start the schematic. Okay. Any questions on the morning session? With the inductor, you want to repeat that part? Okay. So you're talking about the 3 and 4. Okay. Yeah. So if you look at the input and output, please come. See, the inductor and capacitor, because they're single order, right? So one is S omega, one is omega L impedance, one is 1 over omega C, right? So which means that they will basically work the same way, except that it'll be the inverse of the frequency. So one is off in high frequency, the other one is on at high frequency. Okay. So obviously we don't, in IC, we never use inductors. I mean, never in the sense, unless it's like really high RF frequency, we don't use inductors. But they kind of operate the same way. Okay. So in this third one, so you're going to get omega L as your ZC, and if you do a resistor divider, you'll get the transfer function which will look like a low pass filter, right? But intuitively, like I said, if you had a capacitor, you would have it in series here, then that 1 over omega C will become omega C at the top. Here it's omega L on the numerator. So basically they just look like same. Instead, L in the numerator, it is C in the denominator. So capacitor, low pass will be in parallel and high pass will be in series. Inductor, it will be the opposite, because one of them is 1 over omega C, the other one is omega L. Okay, so if you want to switch off one at higher frequencies, you want to use the one which has the omega C on the numerator, which is basically the capacitor, the inductor. Okay. If you want to switch it on, short it at high frequency, you want to use the element which is 1 over omega, because at high frequency it will become short, right? So that's why this is the low pass, that's the high pass. Okay, so it's kind of the sort of the mirror image of that. Okay, so when you're doing board design, then you can use inductors to do low pass design, because you can have big inductors, microfarads, in microfarads for see in IC design, even the bond wire, which is you have the die and there's a big wire which goes and joins the lead pad, those are only in nanohenries. So anything inside the chip, they're in picohenries or attohenries. So you just like they're almost negligible. Okay. Whereas in board design, because the loop sizes are large, they you get inductors actually not easily, but you get inductors, sizable inductors. Okay, like just a PCB, if you just do a trace, like a circular trace, you can get easily, maybe not microhenries, but a couple of 100 nanohenries very easily. Okay, and if you want to go microhenries, then you buy those elements which looks like resistors, but they are wire wound. Yeah, toroid wire wound. Not toroid, but mostly wire wound ones. Okay. Okay. So yeah, so this is just showing that you can use inductor to do low pass filter. So for example, this one, you can see it's turned off. At high frequency, at low frequency, it is basically a short. So, and there is a pole frequency which is L over R, because again, you write the whole transfer function as omega L, you're going to get that K over S plus alpha, right? So I think everyone clear, or you want me to write the equation? I think everyone understands that, right? So if you substitute this as SL R, write the equation, you're going to get the low pass filter. Okay, I'm just intuitively showing you why it is a low pass filter. Okay, and then this one is the opposite of that. At low frequency, it's a short. So basically, it looks like a high pass. At high frequency, this opens up and just looks like a voltage divider. Okay. Again, you put the transfer function as SL, write the whole equation. You're going to get it as S by S plus alpha, K times S by S plus alpha. Okay. Is that clear? Yes. Okay, good. All right. So I just want you to quickly, write the transfer function for this. So just go ahead and write the transfer function, assuming obviously the OpAmp is ideal. Okay. Yeah. This I think leave the fan on a little bit. It's like everyone is just really hard. So maybe just turn down the fan a little bit. Just have it on. Is it okay to have the fan on a little bit? Okay. It's been really humid outside today. Okay, so we're going to create that OpAmp model. You can, so I'll just do it in parallel. You guys can start doing it and follow me, or, be ahead of me, which is probably better. All right, so start a schematic, and then first thing you do is you okay, so bring in the VCVS, just like you did before. Okay. So the OpAmp, although we've been showing 3 terminals, actually it'll be 4 terminals as well, because that output, one of the terminal is basically ground, right? That's your reference. So we'll just keep it same here. So because we're trying to create a symbol, now just wire is not enough. You need a pin, either input pin or IO pin. So typically in analog, you'll always keep IO pin because you have currents flowing in both directions. So I would say, why do you choose between, that's a basically schematic thing. As far as ngSpice is concerned, the netlist will look exactly the same. It's basically the schematic editor finds out if you've made a mistake or not. So what you can do is you do Shift I and search for IO and pick up IO pin. And so you'll have one for the positive output, and then now you can just copy and paste it. So one for the negative output, and for the input, keep it same, and you can flip it. Okay, and then wire it. Okay, and then name the pin. So I'll call this VIP, means input positive. Keep something which is easily recognizable. And this one I'll call it VIM, as in minus, VI minus. And this one we'll call it VOP. And this one we'll call it VOM. Okay. And for now, we'll just hard code the gain, and we'll, keep it 1000. All right, so that's it. You're just taking the VCVS and making a symbol out of it. And you might ask, like, why are we doing it? Well, two reasons. One is we are going to add some more elements to this. And then, in the process, you'll also see how to make the symbol for it and instantiate it in another schematic. So this is a hierarchical schematic editor. So you should be able to, hierarchically put your design into one schematic, drop the symbol somewhere else. Okay. So, yeah, first thing you want to do is save this. So you do save as, and I'm going to call this like, OPA mod maybe. So that tells me it's a model of the OpAmp. OPA underscore mod 1 maybe. Okay. So save it. And to create the symbol, you go to symbol in the menu. There's probably another hotkey somewhere here. A. So you can use A, or you go to symbol, make symbol from schematic. Do you want to make a symbol view? Okay. And looks like there was no error. And you'll find the symbol in that same directory you started the Xschem in. And so if you, when you create the new schematic, you'll be able to drop it in. Now, the thing is that because it automatically created, it just probably took the ports and put it in one side, created a little square and put it. So we're going to like make that a little bit more readable. So start a new schematic and then open, and you should see OPA. Oh, well, go to current directory and you should see OPA mod 1 sim. Instead of SCH, you'll see .sim, just like the other devices. And if you hit OK, so this is actually you're editing the symbol right now. Okay, you're not instantiating the symbol, you have opened the symbol. Okay. Is anyone, you're okay? What? Yeah, so if you, once you are in the schematic, you have the pins and everything. Okay, so just go to symbol and you'll see, I think the third or fourth, it says create symbol. Make symbol from schematic. Okay, and just click that. Hmm. So before you, so let's say you have a very complicated schematic and you have two input ports, two output ports. That you have to put these pins, and that pin you get it from, where did I get it from? Symbol, right? Yes. No, sorry, you do get from the devices library. From your devices library, there is input.sim, there is output.sim. Do IO. For when you're doing analog circuit, we don't use input. In digital circuits, we'll use input output because then you can figure out if you're shorting to outputs or not. But in analog, there is no shorting the output. It's just an analog pin. So in analog, I'll always keep it as IO pins. So that way you're not getting all the stupid errors and warnings and all that. Okay. So you put the pin, and this is just the pin name. Okay. You can call it obviously whatever you want, but having those names, which is has a correlation with what it is doing with the functionality, it's easily readable. Okay. So you can call it like VX or NX or your name or whatever it is, but then when you get the symbol, you have no idea what that symbol means. Okay. So once the symbol is created and you have no error, you open another schematic and then open that symbol. Okay. To open that symbol, you do file read over here and then go to your current directory, and you should find that. So in my case, I have named it as OPA mod 1. You should see a OPA mod 1.sim. Okay. And you'll get a symbol like this. Now you can just take this symbol and instantiate it in a schematic and get it working, but we are going to like modify it a little bit so that it looks like an OpAmp. Okay, so I'll just maybe wait here for a few minutes so you guys kind of catch up. And everyone has a symbol like this already? Everyone's got a symbol like this? Who doesn't have a symbol yet? Okay, so take your time. Yeah. So in the meantime, I'm just going to modify it a little bit. So I'll take the VIP VIM into the input. So in order to change it, you can select it left. So basically what I want to do is I want to take these two inputs to the left hand side. Okay. So I'll select them and press M and move it. And while I'm moving it, I can flip it, Shift F. Okay. Oh, I didn't take the names. All right. So I have to select the names as well, I guess. So M, Shift F. So I get the VIP VIM. And it's probably a good idea to take the minus symbol to the top, right? Because usually we always put the feedback on the top. So that way, if we take it to the top, it will be better. No, you just click and drag the area you want to select. So if you left click, hold and drag it. But yeah, if you select the whole thing, you want to maybe just select. So you can also select by one with shift. So for example, if it is too close to the corner where it is selecting the entire symbol, you can select the pin and select the name, shift and select the name, and then press M and move it out. So I think I should be able to draw. Oh, it's probably a polygon somewhere, but yeah. I would probably avoid that because that usually is used for GM devices. So if you want OpAmp, I would say keep it triangular, but shouldn't matter. But yeah, but the second pin is actually the ground reference pin, so it should be like really the ground pin. All right, while you're doing that, I'll just try to instantiate in a yeah, 1 second. Yeah. Which one? No, yeah, you can change it. Just queue it. Undo. You can press undo. Yeah. Click it. Yeah. Yeah. And just hit OK.
Stop changing.
That's strange. I'll just use. Oh, yeah, I think by mistake you have clicked this. So you see a button here. It says no change properties. That's why it's not allowing you. So you need to deselect that. And then if you, yeah. All right, no problem. I forget what the stretch is. Can I turn the slide? Oh, yes, sure. Maybe can you switch the one behind because it might be too dark. Yep. Okay. Yeah, this. Is that okay? Okay. So you create a schematic, right? This is your schematic, very simple schematic with 2 input pins, 2 output pins. You want to create the symbol so that you can instantiate this in another schematic, because right now you cannot instantiate this. If you instantiate this, the whole schematic will just go in. Okay. So then what you do is you create that symbol create, right? Symbol, make schematic from symbol, correct? And then when you do that, it'll create this file called opampmod.sim, right? Now in this one, you just need this ports, 4 ports, and with their names obviously, and keep the @sim name and @name here. Okay, this symbol name, because when you instantiate this in your top level schematic, so right now you see this is the schematic we've been simulating. You can see it says OP mod 1, right? So that way you know that, okay, this is the OPM mod 1 I created. And this one is the instance name. So if you instance another one, it will be X2, but it will still be OPM mod 1. Okay. So in the symbol, you just have the ports, and these lines don't matter. That's just for drawing for you to know. You can leave it as a square if you want, but have it something which signifies what it, I mean, create the symbol in such a way that it is clear that, okay, just looking at it, I know it's an op-amp. And then instantiate it in this schematic. First, copy this schematic. Okay. So you can open this schematic, your previous schematic, do a save as and name it like mic test underscore OPA, and then remove the VCVS, put your symbol for VCS, and the simulation should be exactly the same. Okay. And the other thing I would advise you to do is go to that your netlist directory, okay, simulation directory, and you open that file, and you'd see how the subcircuit is. So you can see now, instead of that VCVS, it says X1, V out, V in, this, OPM mod 1. Now, OPM mod 1 is actually a sub-circuit. Sub-circuit means it's another circuit now. And if you go down somewhere, I think it should be, yeah. So if you see on the very bottom, it has dot sub-circuit, OPM mod 1, output, input, negative, output negative, and the instance of your VCVS, okay? And this thing is called over there. Obviously, this one has only one element, but this is, we are going to change it, add a pole and all that to this one, okay? Make sense? All right. So do the symbol, instantiate it, and simulate it and see if you're getting exactly the same answer as before. And then what you're going to do is we are going to take this model and add that pole, okay, to get it close to you. And we'll do a high pass filter with this, and I'll show you, what's the difference between adding a pole and having it ideal.